As Jay said, my name's Tim. I've been working here in Brymbo for the past 7 years now. I've been in paleontology, I think, for about 20 years, working several different postdoctoral positions until I landed here. The site, as I'll hopefully describe to you, is pretty magnificent, which is why I decided to come here and plant myself and try and make a career out of it. Just on this title screen, you can see some of the work we've been doing this summer on this exposure, digging test pits that will eventually become foundations for the building that's being constructed right now. That's me there in the fetching orange. So just to give you an outline of what I'm going to be talking about, I'm going to tell you what Story Brymbo is, first of all, and then also what the Fossil Forest project is. I'm going to talk about the recent history, and when I say recent, I mean European recent, so the past 200 years. Also, the discovery of the fossil forest, what's inside it, like why it's so special, and then also the current work we've been performing that is progressing us to actually get a building on the site and start it up as a visitor attraction and centre for science. And then I'll end with what it is that we're wanting to do in the future. So you can see on this slide, this derelict building is what's known as the machine shop. It's part of the old ironworks site that we look after. And this is actually going to become the front face of the visitor attraction that you can see here in this artist rendition. So Story Brymbo itself is a multifaceted community development project, and it aims to preserve and celebrate the social, industrial, and natural heritage of the site. And that's core to our mission, is this tripartite social, industrial, natural heritage. It's a really, really unique site. We have multiple projects on the go, funded to the tune of about £8 million so far. And I'm employed as the paleontologist to look after the Brymbo Fossil Forest project. This project, in its simplest terms, aims to protect, excavate, and interpret the in-situ Carboniferous forest that was discovered here. That means over the next few years, I've got to try and move over 100 tons of rock, curate over 100,000 specimens, most likely. And I'm the only professional working on it. And the rest of my team is made up of volunteers and students. So it's quite a tall order. I keep saying the word Brymbo. It's a weird word, so I'm going to tell you what it is. It's a small mining village, ex-industrial, ex-mining village in the north of Wales, just west of the city of Wrexham and quite close to the border with England. It sits within, geologically, it sits within the Denbighshire coalfield, which is one of the many coalfields that have been historically exploited throughout the UK, much like those coalfields in Canada, America, Russia, etc. And here's just to help you kind of get a picture in your mind's eye. This is an aerial shot of Brymbo. On the left is the village of Old Brymbo, and towards the centre is some of the new developments, the new housing estates that have cropped up over the past 20 years. But as you can see, it's very typical of kind of rural North Wales. Quite a beautiful place to be. The area has a much lauded history of metallurgy, as you can see here. The most important dates on here are that the construction of an ironworks began in the late 1700s under the supervision of John Wilkinson, who's quite a renowned historical industrialist. I think he was responsible for inventing boring, that led to the invention of bored cannon, which would go on to obviously contribute to the British Navy. That ironworks was really, really successful and changed hands multiple times, continued to produce a lot of iron for 100 years until, through the evolution of science and technology, the first steel tap took place on site in the late 1800s. The following 100 years saw that the site expand into a 3/4 mile long steel rolling mill that produced thousands and thousands of tons of very high grade steel, and the area was renowned for it. Unfortunately, in the wake of a lot of the Thatcherite policies of the time, the site was actually closed and dismantled in 1990, and this led to the loss of over 1,000 jobs. This obviously decimated the local community because it wasn't just their place of work. It's talking to the old ex-steel workers here. It was also their community and the kind of their social link to each other. So in a way, there's still people mourning the closure of the steelworks today. Shortly after that, the company came in and bought the land to undertake remediation, which is, for want of a better word, a fancy name for strip mining. They strip mined the entire area that the steelworks was on, down to about 400 meters, to extract a lot of the coal that was under there, and flog that, make a bit of cash, fill it all back in, and then use that to fund development on the site. It was during these reclamation works that the fossil forest was discovered as they moved north towards the old Georgian Ironworks site. So you can see here again, just to help flesh out the image in your head, this is the ironworks in blast during the 1860s. The square structure to the left of the three chimneys is a blast furnace, a Georgian blast furnace known as number one. That's still standing on our site today, and is a very important part of the history. It's quite iconic. On the left here, you can see the extent of that steel mill by the 90s. The yellow rectangle in the top is the site of the old ironworks. So you can see how much this site expanded over time. The red circle is the site where the fossil forest would be discovered. And on the right-hand side, you can see the site in 2015. You'll notice that the steelworks is completely gone and the area looks quite different. A lot happened between then. With these reclamation works, as you can see here. This is looking towards the old Georgian ironworks, and you can see an excavator there scraping out a coal seam to sell. You'll also notice some circular marks in that coal seam, and they're actually the remains of medieval bell pits. So that we know people have been exploiting the mineral wealth of this area for thousands of years, but there's some nice evidence there. So as this reclamation work moved towards the ironworks, they started to notice an increase in the size and frequency of fossil material. Now, whenever you're digging around coal measures deposits, you're going to find plant material. Coal, obviously, is plant fossils. So when you work in these strata, you do come across fossil material. But they, as I said, they noticed that they started to find some absolutely whopping, massive tree stumps, such as this one, as you can see here. This stump is emerging from a coal band underneath and into the surrounding sandstone sediment. Luckily, the guy who was in charge of the reclamation works called a stop to it and got in some local experts. So between 2005, 2009, there was a series of smaller excavations that took place. Now, I lovingly refer to these as smash and grab operations because they thought that the site would be destroyed. They thought that the reclamation works would start up again at some point and the whole area would be excavated. So what they did was extract as many of the most kind of impressive and pristine fossils as possible to save them. However, during these works, they started to realize that actually this is a big deal. This site is quite impressive. So what they did was, while they were excavating, they also worked towards getting the site protected, and they were successful in that. By 2009, the site became a special site of scientific interest. During this excavation period, they produced, my estimate, between 5,000 and 10,000 fossil specimens, and they are what we have been curating into our own collections over the past 6 years with volunteers. So just a little bit of background. I mentioned earlier that this is within what's called the coal measures group, similar to what you have over in Canada and America and elsewhere. However, we know that this particular sequence is in the upper Carboniferous, in the Westphalian stage, and in the Duckmansian substage. So this puts it at approximately 300 million years. With some biostratigraphy, the last estimate was around about 314 million years. So I think a little bit, only a few million years difference with what you have at Joggins. The section that we have on site is one entire cyclothem. So one entire sequence bound at the bottom by a coal seam called the crank, and at the top by a coal seam called the 2-yard coal. In between those two, the cyclophem consists rather typically of siltstones, mudstones, sandstones, and ironstones. And these represent a disturbance in the coal forming forests through braided river systems, flooding, that kind of thing. We also have, that's not on this diagram, a lot of siderite concretions, locally abundant in particular strata. So these are ironstone nodules. I think they're 34% siderite. They are absolutely solid, but if you have the time and the energy, you can crack them open. And I'd say about 50% of the time, you find an absolutely beautiful fossil inside. So we spend a lot of time doing that. Here you can see, just for context, the globe as it was 300 million years ago. In yellow towards the top, you can see the position of Wales today. And in red, by the equator, you can see the position of Wales at the time. So we were smack bang just north of the equator, right in the middle of this equatorial coal forming forest that would have run from South America through North America, Canada, into Europe, through Russia, up through China, and eventually down into Australia. So I always say when I'm giving talks and tours that, you know, and if you can think of anywhere that's producing coal en masse today, that's where these equatorial coal forming forests would have been. And just for context, it's approximately where Joggins is, and you can see we used to be much closer together, pretty much neighbours. I always refer to Joggins as our sister site, unofficially. And you can see that you know could have travelled between the two relatively easily before the separation caused by the Atlantic. So what we think happened at Brymbo is very similar to what happened in a lot of other coal forming forests that lead to the preservation of them, which is you have these extensive swamps, although Brymbo is slightly different in that we think it's more of an upland swamp. Now, when I say upland, it's relative. Upland in the Carboniferous is 10 to 100 foot, right? A lot of these plants are tied to water systems. They reproduce via spores and need to be close to water to reproduce. Seeds were only just evolving, so there was not a lot of flora inland. Brymbo was slightly further up away from the deltaic environments, and we think that's the case because we have no marine intervals in our sequences, and a lot of the geochemistry comes back supporting that as well. However, being slightly upland didn't protect it from these periodic catastrophic inundations, and thousands of tons of water would be washed into these environments semi-regularly by tropical cyclones dumping water in the inland deserts that would wash out, burst the levees, and bury the tree stumps and knock over standing trees. Eventually, these waters would recede and the wetland would be recolonized through succession. Plants would re-establish themselves, forests would grow. The dead organic matter that was produced would form as peat, and that would obviously eventually be compressed as coal. And you can see these repeated cycles at Brymbo. In fact, if we look at the small exposure that we have at the front of the site now, you can see two sandstone lenses at the top of the section here. These are interpreted as a bifurcating river channel that's been infilled with sand that's been flooded into the area, possibly by a burst levee. We think this channel is bifurcating because of this tree stump that is unfortunately decaying. It's a giant lycopod, and it was originally much larger and reached the top of the section. This is further supported by the structures that we see within these channels. They are bedding in a way that suggests they are migrating outwards as they fill, and that loading is causing the underlying siltstone beds to be deformed, as illustrated here. So even without excavation, we are able to show just how dynamic this terrestrial ecosystem was. So we're going to start talking about some of the stuff that was recovered in these initial excavations and what we know about the flora and fauna of the Brymbo site. Unsurprisingly, one of the dominant forms of plant life during this period in this site are the lepidodendrales, giant scale trees, very, very characteristic of the time. They're related to modern club mosses and again, reproduced via spore, so needed to be quite close to water at all times. They dominated the upper canopy in their various forms. It's estimated they've reached between 100, 150 foot at their highest, so monstrous, monstrous plants for what are essentially giant mosses. And the material that they are represented by in the fossil record is varied. Lots of different parts of the plant were discovered at different times, and that has led to different morphospecies being described. For instance, the top image there is the spore cone, Flemingites, attached to a branch which we call regionally Lepidophyloides. And you've got the bark below that, and underneath you've got the roots, Stigmaria ficoides. So all of these different species coming from the same organism creates a lovely taxonomic problem that we deal with on a regular basis. The rooting systems are really cool. We've got plenty of them on site. They're really, really shallow and really, really extensive. 20, 30 foot is not uncommon for a single root. They are really odd. And if you imagine they have no taproot and they just have these really extensive, shallow rooting systems. They also produce a ton of leaf litter in the form of cyparites, which are essentially the individual leaves that grow out of the leaf cushions, the scales on the bark. These are superficially similar to pine needles, which is probably where the name cyparites comes from. And yeah, we have them by the thousands. Here's an example of one of the larger stumps that was recovered during those initial excavations. As you can see, this is an absolute monster. They're really well preserved. They still have coalified bark on the outside in a lot of cases. This one, part of it is still with us. And unfortunately, over the 20 years since its excavation, the lower section has unfortunately disintegrated. However, I managed to get a 3D scan of it before it did. So I'm hoping to be able to reconstruct this at some point. And one of our most famous specimens, referred to as Big Stig, came out during this period. You can see here, this is a medium-sized lycopod trunk, but it rather uniquely has the entire root system preserved. This doesn't often happen, as we saw in an earlier picture. A lot of these trees are rooting out of the forest floor, which is essentially peat. When that's compacted and turns to coal, it destroys any of the root systems that are in there. So you usually end up with a trunk just protruding from a coal seam. In this instance, this particular plant was rooting into a sandbank, and therefore, when it was filled with sand during that flood, it resisted compaction, and the entire root system is preserved. This was subject to some seriously good curation and restoration, and it's now on display in the National Museum in Cardiff, South Wales. The second most common component we have are probably the horsetails, the equisitales. They are so abundant. We have hundreds on the surface of our site already. Only 2 species that we have here, but they are really good examples of a morphology that's just stuck. These things, as you can see in the middle, with rather serendipitously, we have living horsetails on the fossil forest site, so growing alongside their fossil counterparts. And you can see the morphology is almost identical. You have these vertical striations in the internode, separated by nodal segments. Hasn't changed. I often refer to them as the sharks of the plant world. They hit a body plan that was so good early on, hasn't changed. And it's thought that they did the same thing in the Carboniferous. They were really opportunistic. It's likely that whenever the environment was disturbed, these guys reproduce asexually a lot of the time. So they just swooped in, grew as quickly and reproduced as fast as possible before being outcompeted through succession. The only difference with these guys in the fossil record is that they grew to about 10 meters tall rather than, 20 centimeters tall. So they were a significant part of that kind of the borders of these forests along the rivers and riverbanks. The mid canopy plants that we have here are quite rare which is really weird. I'm still trying to get my head around why this is. So the Medulla sales, the extinct seed ferns, um, we only find a few leaf fossils, and they seem to be extremely restricted to particular layers of sediment. It's an ongoing puzzle. I'd expect to see a lot more of these, but we don't. You can see some of the beautiful leaves that have been recovered here on the left. What is weird is that we get loads of these guys, the Ligonopterodales. These are climbing ferns. They are locally abundant, and when I say locally abundant, I mean in the hundreds of thousands of leaves and leaflets that we find of these things. And it's almost monotypic. Almost exclusively this guy, Carinopterus jacuti. This particular species is a real thorn in my side, shall we say, in that it appears to be morphologically heterogeneous. The specimen you can see on the left, the pinnules on of the leaves are quite variable, quite lobed in places, quite wide. And then you look at the specimen on the right, which is categorized as the same species, but has very pinnate, uniform pinnules. These are apparently the same species. I would love to get a student in to study this, to figure out if this is really the case, if we have a cryptic species complex, if these differences are the result of ontogeny. I think there's an interesting project here. But yeah, these are the climbing ferns that we get associated with these plants. The last plant I'll talk about is this little guy and the Urnotopterodales. This is a small scrambling fern that's actually more closely related to true ferns that are still alive today, rather than the extinct seed ferns that we just talked about. This particular species, Xyleria fosteri, is endemic to Brymbo. It was described from our site. As far as I know, it hasn't been described anywhere else yet. Rather interestingly, Barry Thomas, the paleobotanist who described it, named it after Andrew Foster, who is the foreman who called a halt to the works that preserved the forest site. He's actually one of the trustees of our project now as well. So of the 2,000 odd fossils that we've catalogued to date from our site, 14 are animals. Disappointingly low number. This turns out to be about 0.7% of all the material recovered. I don't know why this is. I don't know if this is a true reflection of the diversity. I don't know if this is collection bias based on paleobotanists' work in the site, or it could even be taphonomic bias, so some preservational interference that prefers plants over animals. This is an interesting area of further study that I'm looking forward to getting people involved in. But of the animals recovered, we have a mainstay, a staple of coal forest environments, Euproops. Wonderful name for a tiny little horseshoe crab. Interestingly, this particular genus is thought to be exclusively freshwater. So these little things were knocking about in all the little rivulets and braided river systems in these coal forests. It's a beautiful little fossil. We also get pygocephalan crustaceans. These are the target of studies being done by me at the moment. It's likely they were filling crayfish-like niches in these river systems. However, they're actually within a group of crustaceans called the Pericarida. So they are technically more closely related to woodlice than they are to any modern shrimp. So this is likely another instance of convergent evolution in crustaceans to becoming shrimp-like. I'm sure you've all heard of the everything evolving into crab meme. Well, crustaceans do a lot of evolving into shrimp as well, and this is another instance. I've studied these for a little while now, and I'm starting to collect some information that seems to suggest this might be a new species from Brymbo itself. Yeah, keep your eyes peeled for that. So by now you should have some idea of the kind of the scope of the work that can be done here and the opportunity that it presents, which is why the Heritage Trust proposed that a building be constructed over part of the site to excavate it in situ. we plan to do this in quite a unique way in that we're building this temporary structure over it. We will excavate it with our volunteers and students, but the entire time it will be accessible to the public. In these diagrams, these artists' kind of renditions of what the building is going to look like, that top part of the building is a 40-foot container that will be an observation deck where visitors can come and have a look, talk to us while we work, pester us while we work, ask questions, all kinds. And that's something I'm really passionate about is trying to break down the ivory tower, make paleontology and its associated earth sciences less exclusive and much more accessible. So I want to be pestered by kids who have a real interest in what we're doing. So I'm really excited to get this building up and running. In order to do that, we had to dig some foundation holes. Now, rather than let the contractors that we've employed do this and potentially damage any important specimens, we thought it was a good opportunity to test our excavation methodologies and also as an opportunity to drive engagement with the project. So we said we'd do it. So we dug 4 pits for foundation posts, as well as a trench towards the top of the exposure that would end up becoming a concrete pad for the observation deck. This was all done really quickly. We got permission to start on our project late spring, so we jumped into action in about 3 weeks and managed to engage 19 students from 7 different universities to come along. And we trained them up and had them work in 1 week blocks. We provided accommodation and food for them, and it was a blast. We had loads of fun. It's so nice to have so many people who are passionate, enthusiastic about paleontology and earth science together, digging out fossils and finding new things together. I won't lie, it was all about the extra hands. We needed to get this done as quickly as possible, and these guys really helped us do that. So we shifted a lot of rock during that period. I'll show you now some of the things that we found during this period, just to give you an idea of just how productive and prolific the fossil material on this site is. This is pit 1 towards the bottom left of the site, and the red outline is the footprint for the foundation pad. You can see at the top there, we discovered a thicket of 5 standing in situ Calamites horsetails. Really beautiful example of how these things grew. And then to the right of that, a prostrate section of a horsetail trunk. We measured it at about 4 foot, 4.5 foot before we finished excavating it. And rather than remove these, we talked to our contractor and we've come up with a solution that will actually protect these fossils underneath the concrete pad. We plan to expand the building at a later date where we can recover these properly. This is towards the middle of the stratigraphic section, so just above where our siltstone is and into where the sandstone channels start to form. So these things are likely to have been buried early on in the sequence of disturbing events that are represented in the cyclothem here. Here's a really nice shot of those Calamites up close. You can see how they've been infilled with the sediment, and how there is some compaction. You can see some crease marks. We also recovered this lovely specimen in the bottom right that shows how these things propagated from fallen branches. They would shoot off new shoots to become standing aerial plants. And you can see evidence of that. It's really, really nice. I also started to notice during this excavation, the Calamites that we're pulling out, a lot of them had these weird grooves pressed into the casts. My current theory is that these are strangulation marks from some of the climbing vines. They're ubiquitous across most of the Calamation fossils that we have. So that's another thing that I would like to test moving forward with the help of students. Excuse me, in pit 4, which is slightly further up the stratigraphic section into the massive sandstones, which represent a kind of stable influx of sediment and water, likely via migrating river channels. You can see that we discovered in circle A there the top of a lycopod tree, rather large one, and in circle B, you can see an accumulation of flotsam consisting of broken calamites and also lots of bits of lepidodendron branch. To the bottom of that B circle, you might be able to notice a curve in the actual rock face. That is a naturally occurring smooth curve in the sediment, which really puzzled me to start with. But after we found these features, it started to make a bit more sense. What I think we have is something that was actually identified at Joggins, which is a vegetation-induced sedimentary structure. So what I'm thinking is that the migrating river channel running through the area came up against this tree stump, and the flow bifurcated around it, causing a small eddy to the bottom there that smoothed the sandbank and deposited a lot of flotsam. That's my running explanation. However, time will tell. Here's some close-ups of those points of interest. You can see the top of the lycopod stump on the right with the bark impression, a little bit of coalified bark, and some modern roots that have worked their way down in there. And on the right, you can see some of the detail for those preserved lycopod branches, the bifurcating branches that still have the leaflets attached, which to me indicates that they were torn off rather than shed. Along with some of the beautiful scaled patterning on the bark. You can also see a few horsetails in there as well. And then the top trench that we dug is further up the section still, just below the coal seam, and shows all the hallmarks of being what's called a seat earth. So this is the last bit of sediment before the forest reestablishes itself after disturbance, hence the coal seam above it. Now this layer is absolutely jam-packed full of stigmarian root systems. You can see in the top picture there my foot against the leg of a tree stump that's bifurcating into root systems. And in the bottom, this is a bit more difficult to see. There is a black lens which represents the top of another tree stump rooting further down that has collapsed under the weight of the sediment to form a lens. You can see some of the coalified bark on it. The arrows here represent stigmarian roots moving through this layer, hitting the top of this buried tree stump, and then moving in another direction. This is not something I think I've seen in literature before, so this is another nice area that needs looking into. You can even see that the top stigmarian root hits the tree trunk, and as it moves along it and moves away, it actually takes on the imprint of the bark on one side. This is that site as of yesterday. Contractors are on there, putting the casing up for the foundation pads now that we've finished. So things are moving really, really fast. Here's a more detailed schematic of the building itself. And in putting this building together, we've had to take a lot of things into consideration. So we wanted to do this right the first time. So we've spoken to a lot of paleoconservators and curators and other people to make sure that, you know, we're creating an environment that's conducive to both our operation and the survival of the material that we're going to be collecting. So this original sketch, the building is black. We're now scrapping that, and it's going to be a lighter color to help us control the temperature. The roofing is also going to be changed, and we're going to insulate the walls to help us control humidity. We're also increasing accessibility within there by building decking and plank and gangways to get about. We're purchasing local dust extractors to prevent any respiratory problems while we excavate. We're also coming up with solutions for storage space because we are running out already. We're producing so much fossil material, it's unbelievable. Here's just another schematic of what that top interpretation container might look like. We'll be decking it out ourselves, but we want to make it as accessible as possible so people can talk to us and we can interact with them while we work. And here's some nice interpretive images of what might what the interpretation within those containers might look like. So moving on to the future. Now, bear in mind that I thought this project was going to start 6 years ago. We have faced numerous legal, political, financial hurdles that, through sheer tenacity, teams managed to overcome. Now the project started, everything is moving incredibly fast. And even the building itself, we expect the building to be finished in April of next year. And we're hoping to be open that part of the project by Good Friday. So this building will allow us continuous excavation throughout 12 months a year, which is not something you often get with paleontological digs unless you're close to the equator. We've already got interested undergraduates and postgraduates lined up to come and work with us from 9 universities in the UK. And we've already blocked out 3 months of student time in our calendar that will allow for those students to come work with us on what we're doing, while also gathering information from their own undergraduate projects and theses. The goals from this point onwards are for me to try and establish the fossil forest as both a premier scientific tourist attraction as well as a respected centre of paleontological research. So, no small order. I'm really interested in trying to increase the accessibility of the fossil forest, both conceptually as making earth science more interesting, and physically as in trying to get more demographics involved as well. I'm also interested, might be a bit pie in the sky, in trying to set up a Carboniferous fossil forest network. We're not the only one out there. There's obviously Joggins, but there's a few others knocking about. And I think we probably benefit from working together a bit more regularly, and leaning into each other's strengths. There's a lot of these sites around the world, and each one could complement. We could complement each other in our differences. As mentioned earlier, I will be traveling out to Joggins. I'm having a little jolly. I'm going on a trip funded by the Churchill Fellowship. I'll be spending a week in Joggins from the 15th to the 22nd, and then I'll be hopping across to the Royal Tyrrell from the 22nd to the 30th. The aims of this trip are relatively unacademic in that I'm coming out to see how these institutions are run, why they're successful, how they're successful, and what your and how you've managed to become inclusive in your engagement, and the different methods that you've used to successfully communicate those sites to the public. So looking forward to that. So with that, I will finish, and I'll be happy to take any questions